So the previous video on introducing rates of change discussed how the slope of a secant line, the slope between 2 points on a curve, is an average rate of change, and the slope of a tangent line at 1 point on the curve is the instantaneous rate of change, which we can also call the slope of the curve. A third type of line that we look at is what's called a normal, and a normal is like a tangent line in that it goes through 1 point on a curve, but it's perpendicular to the tangent line, meaning that its slope will be an opposite reciprocal of the slope of the tangent. So if we wanted to find the equation of a normal line, which I know sounds a little strange that way, but that's what it's called, normal meaning perpendicular to the tangent line. It is a line, so that means we do need to know a point, and we need to know the slope. Well, the point is just the point on the curve that we're looking at. So in this case, if we're looking at the function 4 minus x squared, when x is 1, the point is at 1, and then when I plug 1 in for x, 3. For the slope, I first would need the slope of my tangent. Well, that means I have 1, 3 as one of the points, and then I want to point just a little bit to the right of it. So I would need to know f of 1 plus h minus f of 1 over 1 plus h minus 1. And then I want to move those 2 points infinitesimally close together, so I'm going to do the limit as h approaches 0, since h is the distance, the horizontal distance between those 2 points. So, haven't found the limit yet. If I plug 1 plus h in, I'm going to have 4 minus the quantity 1 plus h squared. Then f of 1 is 3, as I already know. In the denominator, the 1's cancel, leaving just h. Well, I can't just do substitution for h here because I'll get 0 over 0. So I'm going to try simplifying it a bit. So if I multiply out and distribute my subtraction in the numerator, I'll notice that 4 minus 1 is 3, minus 3 is 0, so these are all gone. And I can then cancel out an h in what's left. So I'll have the limit as h approaches 0 of negative 2 minus h. Now I can go ahead and do substitution, and when I plug 0 in for h, I get the tangent slope is negative 2. However, the slope of the normal is the reciprocal of that, the opposite reciprocal, I'm sorry, which would be positive 1/2. So now that I know a point and I know the slope, I can write in point-slope form the equation of the normal, which should be y minus 3 equals the slope of the normal times x minus 1. And there's the equation of our normal.